For almost 5 billion years, the energy stored up in our planet has sculpted, twisted, and structured the Earth's crust, leaving behind it mysterious geological traces. The Pyrenees Monte Perdido site, radiating out over the Franco-Spanish ridge of the Pyrenees, is one of the most impressive of these marks of the passing of time. Hollowed out in the heart of the Pyrenees, 4 exceptional cirques, Givanni, Estobé, Trumuz and Barud, make up the French part of the Pyrenees Monte Perdido site. In Spain, the Pyrénées Valley, the deep canyons of Anisclo and Ordesa, along with the Esquain Gorges, complete the site. And in the centre, Monte Perdido, the highest limestone mountain in Europe, rising to over 10,990 feet. These 30,000 hectares, listed as a World Heritage Site by UNESCO, have always questioned man on the mystery of their birth. The history of the discovery of the site really begins with one character, Louis Ramon de Carbonnière. Traveller and savant during the Enlightenment, his exceptional research into the origins of the Pyrenees led him in 1802 to attempt an extraordinary feat, the ascension of Monte Perdido. With the means available at the time, the climb was dangerous and difficult, but the expedition succeeded. He immortalized the moment in his book, Travels on Monte Perdido.
Here we are on the edge of the huge edifice. You can't believe your eyes. You look around for help, for comparisons. Nothing doing. How restful this gigantic place is, where centuries pass more lightly than a year down there.
Over 200 years after his adventure, scientists are still enthusiastic about the discovery made by Ramon de Carbonnière at the summit of Monte Perdido.
What Ramon de
Carbonnière discovered here in 1802 sent shockwaves through the scientific world. His discovery was just this. These fossils, these oysters and other polypries, prove that at one time, that's about 80 million years ago or less, the sea covered the whole of the Pyrenees, including the Monte Perdido, where we are at present. The shockwaves were due to the fact that his contemporaries believed that the sea occupied only the lateral parts of the mountain chains and not the high points.
But how did sea fossils get to an altitude of 10,900 feet? Recent erosion has opened veritable geological windows on the past and enables us today to discover the depth of mountains. From the rock laid bare in this way, like here at the Gloriette Dam at the foot of the Estobé Cirque, we can understand the phenomena which resulted in these fossils being found so high up.
We are in front of a rock which, in a certain way, holds up the mass of the Monte Perdido. This is the famous Givanni migmatite. Very old rock, over 500 million years of age, which was later transformed and violently deformed.
To understand how old rock pushed up more recent rock to great heights, you have to go back in time, to the beginning of the primary era, 500 million years ago. At that time, the planet was very different from the one we know today. In place of the Pyrenees was an ocean, stretching to the South Pole, in which sedimentary rock accumulated. Starting 400 million years ago, great tectonic movements transformed the surface of the Earth, compressing these sediments and giving birth to a gigantic chain of mountains comparable to the Himalayas today, the Hercynian chain.
This Hercynian mountain range was completely eroded in the space of a few tens of millions of years. You have to imagine this great Hercynian mountain range slowly washed away by blowing water until it was a completely flat and widespread plain.
Completamente desgastada y muy extensa.
Between about 250 and 100 million years ago, this plain was covered by very shallow seas, which would result in a new layer of sedimentary rock. This more recent rock thus covered the old Hercynian rock.
However, nothing can stop the passing of time and the forces of nature. Soon, the African plaque pushed the Iberian crust northwards. The latter soon came into contact with the huge European crust, which stopped its advance to the north. And there we have the birth of the Pyrenees that we know. In the contact zone, the Iberian crust, made up of Hercynian rock, was compressed and split up by the European crust. On the Pyrenees Monte Perdido site, this crushing movement led to a piling up of the old land which lifted the recent sedimentation which was found on the summit of Monte Perdido. The sea was pushed back southwards, while the mountains rose in the north. The following geological events led to the site being listed by UNESCO as a World Heritage. In 1903, a geologist, Arthur Bresson, made an astonishing discovery: the thrust sheet.
Antes de Arthur Bresson, todos entendían.
Before Arthur Bresson, everybody thought that old rock was always to be found below modern rock. But Arthur Bresson was the first person in the Pyrenees to describe old rock positioned above modern rock. That's what we call the thrust sheet.
To explain such a phenomenon, we must continue to examine the passage of time. From 45 million years ago, as compression went on, the old land went on rising higher, and some of it found itself on top of recent sedimentation. A fine layer of recent sedimentation was thus to be found between two older layers. At the time, these compacting movements always took place below sea level, but today, following recent erosion, the results are clearly visible.
Here we are on the Espugay Plateau. Opposite us is the magnificent panorama, which shows the thrust sheet, with, from north to south, its root zone, its body and its southern front. And we can especially observe, opposite us, the old Hercynian land, which was displaced well over 5 miles to the south, and which lies on a thin strip of recent sediment, itself lying on migmatite.
Between 45 and 35 million years ago, the piling up of the shifted land gradually formed the relief on the north side, but the recently upheaved layers began to slide southwards and deform under gravitational thrust, then steadied as there was no slope. That's the last zone of the thrust sheet, the settling, the end of the voyage for the rock. This phenomenon is particularly visible at the Goris Refuge at the foot of Monte Perdido, where you can see the folding of the rock buried under horizontal layers. "35 million years ago, the Pyrenees Monte Perdido area was above sea level. The climate was warm and damp, and another basic phenomenon appeared and progressively shaped the land: erosion. For more than 30 million years, the water falling on the surface of the earth altered the rock and transported billions of tons of debris down the rivers to the sea. That's how valleys were formed. 200,000 years ago was the Ice Age, and temperatures fell drastically. Snow piled up in the valleys, forming huge glaciers which sometimes reached over 2,600 feet thick.
Today, global warming has melted most of the Pyrenean glaciers. However, there remain a few vestiges. For example, the north face of the Monte Perdido, or in the form of névé, like here, at the foot of this Pyrenean peak.
How can ice change a landscape so much? What better example could there be than the Givanni Valley and its world-famous cirque?
To understand how these cirques are formed, you have to imagine the behaviour of the deeply cracked limestone when the waterlogged Givanni thrust sheet moved in.
Gavarnie égorgé d'eau. L'eau,
The frozen water split the rock and by a rising erosion movement nibbled away at the mountain to reach the frontier ridge. That's the case for the example with the Roland Breach, where the Odessa and the Givanni cirques meet.
se donne la main.
The same forces formed the Tremouze cirque, which is not as high as Givanni, but is impressively 2.5 miles in diameter, and the Baroud cirque, which constitutes the eastern edge of the Pyrenees Mont Perdu site.
Lors des périodes de dégel, ces blocs
During thawing, blocks of rock, some of which were the size of a house, were carried off downstream by the glacier.
ils raclent le fond de la vallée ainsi que les
The
bordures
scraping of the bottom of the valley and the edges resulted in this characteristic U-shape.
si caractéristiques.
On the Spanish side, some of the valleys are mainly the result of ice erosion with the typical U-shape. It's the case of the almost 2-mile-wide Pineta Valley. Its neighbour, the Odessa Valley, shows layers of sedimentation revealing the different strata accumulated over millions of years. Some of the fossils found there are extraordinary.
It's
the most spectacular fossil we have found in Odessa. A complete crocodile jaw. A marine and tropical crocodile, which proves that 50 million years ago, Odessa was underwater with this kind of sea life.
The Anisklo Valley, following ice erosion, was shaped by another grandiose phenomenon, fluvial erosion. These deep gashes, constituting one of the biggest and deepest canyons in Europe, began only 5,000 years ago.
Here we are in the Anisklo Valley. As we can see, the upper part remains typical of ice erosion, whereas opposite us, what we can basically see is typically fluvial, steep-sided. The water exploited little cracks to seep in deep, dissolve the rock and create this big, open, but finally steep-sided valley. The water also advanced underground. That's what we call karstic shaping. That water flowed a long way through the rock before finally working its way back to the surface in large quantities.
The neighbouring peaks feed the famous resurgences in the Esquane Valley. These karstic networks are among the biggest in Europe, flowing out of sight in the heart of the mountains, with about 3,600 feet of difference in altitude. They reappear as waterfalls in the Esquane Valley, opening a path southwards beyond the Pyrenees Mont Perdu site. It took 500 million years to shape these landscapes with their incomparable geological originality. Within a few miles, the site offers visitors the opportunity to discover large glacial cirques, including at Givanni a 1,400-foot waterfall, one of the biggest in Europe, then to continue their climb up the limestone mountain par excellence, Monte Perdido, and finally to come back down by way of two of the deepest canyons in Europe, Anisklo and Odessa. A trip to Monte Perdido is more than just a stay in the mountains. It's the rediscovery of the extraordinary forces which are vital to our planet. Inexorably, these forces are at work just under our feet as the African plaque continues its tireless march northwards.